Oh, good morning, everybody. Welcome to our Power Hour on Modbus. We get started here. So today we'll be going over some of the basics of the Modbus protocol, as well as the live demo using NCD and Orion and Onyx Meter to kind of show you how Modbus functions in an Orion. I'm Jeremy. I'm the Senior Vice President of Engineering for NovaTech, and I've got Brett, one of our sales engineers, will be tag teaming this Power Hour for you. Just a little couple things for anybody that's not been on a Power Hour before. In your GoToWebinar control panel, there is a panel for questions. So if you do have any questions, feel free to type those out and send them to us. We'll try to answer them either during the webinar if we can. If not, then there will be a follow-up email after the webinar with all questions answered, sent out to everybody. And with that, we'll get started. The agenda today, we're going to kind of go over briefly what is Modbus and a little bit of history, talk about the registers and data types. We'll be also talking about some of the Modbus function codes. We won't go over every function code and bore you to death, but we'll go over a few of them. Then Brett will be doing a demonstration, live demonstration, and then we'll go through our follow-up and questions and that sort of thing. So what is Modbus? Well, Modbus is an application layer messaging protocol. It's layer 7, level 7 of the OSI model, the application layer. It's been traditionally used in industrial applications. It was created by Modicon specifically for PLC communications, and then over the years it has spread. It's one of the most popular protocols out there. It is an open protocol now, maintained by the Modbus organization. If you need the specification, you can get it from modbus.org. But nowadays, Modbus is used even outside of the industrial space. It's used often in the solar and other renewable applications, as well as in other utility applications. So like I mentioned, it's an application layer messaging protocol, and it's a client-server communication. And it can be between devices on different types of buses. So say a serial bus could be a RS-232 or 485, TCP/IP. So Modbus, a TCP over Ethernet, which is nothing more than Modbus serial encapsulated in that TCP. And then there's Modbus Plus, not used as much anymore, but was a high-speed token network. And you can see, any device on any one of those buses could communicate with another bus. It is, like I mentioned, a client-server protocol. So you initiate a request. You can see there's in the request, there's a function code, and we'll get into what the function codes are, and the data request. That part of the message is called a protocol data unit, a PDU. So that PDU then goes to the server. The server accepts that, parses it, performs the action, initiates a response, which is another PDU, and the client receives the response. There is, an exception to that. If the server accepts the message, but maybe doesn't support the function code, or there's something else wrong, there is another PDU called the exception response PDU, and that would give you an exception function code and the exception code to let you know what failed. A little history, Modbus, it was developed by Modicon, as I mentioned a little earlier, as a serial protocol. It was for use with their Modicon branded PLCs. Then that was in the late 70s. In the late 80s, Modicon, its parent, including Modbus IP, were acquired. And new owner would be Schneider Electric. In the late 90s, Modbus TCP was developed. Again, that basically encapsulated Modbus serial. And then in 2004, Schneider Electric transitioned Modbus to the not-for-profit Modbus organization. And the commitment was that it needed to be maintained as an open standard. And one of the things I like to mention to people about Modbus as an open standard, it's extremely open. In that vendors across many industries have done little tweaks to Modbus. They have made changes. They've made changes. They do things slightly different, and the standard isn't super strict, let's say. So that's something as you're working in Modbus, you may notice over times is sometimes addressing can be a little different, sometimes function codes, certain function codes, and we'll get into a little more on this. Modbus IDA, the architecture for the distributed automation. This was a capture from around 2004, 2005 timeframe. When the ARC Advisory Group, which is a leading, analyst firm for the industrial automation space, they found that in 2004, Modbus TCP was the top industrial Ethernet protocol in terms of units shipped. So it's been around, it's huge, it's still heavily used in many industries. Modbus uses registers to hold its data. They are 16-bit registers. It can be looked at as holding a 16-bit integer or 16 binary values. There are also single-bit registers, which are coils and binary inputs. And as you look at a device, some manufacturers have decided they'll always use a 16-bit register for all their data. Others may use the 1-bit, coil reads and binary input reads, but there's no rule that you have to do one or the other. For larger integers, you can have consecutive registers used. So a 32-bit integer is 2 consecutive registers being read. There's a standard Modbus register numbering convention according to the standard. 0x are coils. You can read a coil, you can write a coil. If you've done PLC programming, you'll know what a coil is. It's basically you could look at it like the coil of a relay. They're numbered 1 to 9999, or if you want to go all the way to 65535, they are numbered 1 through 65535. But in that instance, when you are going that large, you must include the 0 in front of that number. As you look through this list, there's discrete inputs, the 1x, input registers, 3x, and holding registers, 4x. If you did not include that 0, that leading 0, let's say you wanted to read coil 40001, how would the system know the difference between holding register 40001 and coil 4001? So you must appear as 04001. So it's a way for you to extend that, the access to more than 10,000 registers. It's the best way to put it. Individual bits can also be referenced in standard convention. This is standard Modicon convention, and that is, the register and the bit number. So indicating the 7th bit in register 10001. So some of the common used Modbus data types, binary inputs might be a 1-bit discrete, like I mentioned before. Those are 0x or 1x. One register integer, so 3x or 4x, and that's where you could read each bit of that register. There's also something called exception statuses. This is, and I don't have a slide on this, but function code 7 is exception statuses. There is no such thing as a 7x register in the Modbus protocol. In the Orion, we instituted what you would consider a 7x register, so that NCD and the Orion would differentiate exception statuses compared to, let's say, a 4x or a 3x register, or a 0x or 1x. So that's something, when I mentioned earlier that Modbus is open, it's something that we did, and something that not every vendor does the same way. Binary outputs, you have your 0x, either 1-bit, single, close, open, close, 2-bit, close pairs. Your analog inputs are your registers in 16-bit, 32-bit, or 64-bit if you want to read 4 registers at a time. And then you also have your 1 register integers, your math write. Sorry, this should say analog outputs here. 1 register integer, your 1 register mask write. This is where you can write over individual bits in the register without doing any changes to the other bits in that register. And then a 5-register pulse. And these are some of the common ones. There are lots of other ways this can be done. And all of this is done with function codes. Function codes are it tells Modbus what you want to do. So some of the standard function codes, these are the public function codes, if you will. Function code 1 is reading coils, function code 2, reading discrete inputs, and so on and so forth. There are also user-defined function codes, and those user-defined function codes, they can be set up differently by each manufacturer. So, you have to be careful if you're not sure one device talking to another device, and if they are using any user-defined function codes, it may not work properly. Function code 1, this is the ability to read coils. It can read a continuous status of coils from either 1 coil all the way up to 2,000 coils at a time. The first coil specified, the address of the first coil specified, and the number of coils is how that PDU is set up So the starting address, the quantity, and then there'll be a response. Function code 2 is reading discrete inputs, and very similar. It's either 1 all the way up to 2000 continuous, discrete inputs. Function code 3 is reading holding registers. One of the things I like to mention in this is sometimes people will get a little confused, and especially when we get to function code 3 and function code 4. Function code 3 is reading those holding registers. Holding registers are 4x registers. And when we get to function code 4, which is reading the input registers, those are your 3x registers. It's somewhat reversed there, but it's a thing to understand as you're doing a lot of this. In some writing function codes, so function code 5, if we want to write a single coil, this is to write an output to either an on or an off. This is used quite often. If you want to issue a command, that's one way to do it. Write a single register. So this, you specify the address of the register and then the data in that register. So you can write an entire analog value, let's say. There are also other function codes that I didn't really want to get deep into, but there's a function code 22, and I'm not sure if Brett will cover some of these in the demo, but function code 22 is a mask write. I mentioned it earlier. That's where you can write to a register, but you can write individual bits to that register. Of course, to be able to do any of these function codes or any of the function codes I mentioned before, the devices on both ends must support that function code. If the device doesn't support the function code, then it will respond with that exception response and let you know it doesn't support that function code. So with that, I'm going to turn it over to Brett and let him go through some more detail using NCD and an Orion.
All right, thank you, Jeremy. Okay then, so I'm going to do the Modbus demo, mostly in NCD. In the course of doing that, I'm going to go through all of the settings that you'll see especially for Modbus client, but I'll touch on the other modules also. To kind of set the stage for you as far as what I'm going to be showing and really the hardware that I'm working with that I'm going to make the program for in NCD. Let me get us to the next slide here. As the client device, I'm using an Orion MX, and when I'm in NCD, I will be programming that Orion MX. The device I will be communicating with is another demo device I have here in my office. That server device will be a Bytronics M660 meter. So I've got those both with me, and you'll see, the Orion MX will be pulling that M660 device. So as I get started, let's set the stage here just by showing you on my web browser here, I have the Orion MX. I've got that up. Of course, we'll be working in here a little later as soon as we make up the program. We will also be working with the Bytronics M660, and you'll see I have the list of points here, kind of the standard point list that will be deriving our point list from that will load in NCD. So with that out of the way, here I am in NCD. I'm going to create a new file for my Orion MX. So here under model, I will select MX. It's not one of these expanded chassis, so I'm not going to select 2S or 4S. It's not a cascaded file. So I'm going to click OK here. And now when I'm going to set up a Modbus protocol instance here, I'm going to go into the file. If I'm setting it up on a serial port, I'm going to go under serial, and I'll see my Modbus options right here, client or server. And just really, I'm going to do the programming in a network as a network configuration, because that is how I'm connected between these two devices. For the sake of just being able to compare the screens, I am going to load a serial Modbus client. So let me bring that up, and I'll just put it on the right side of the screen. Now, again, I'm going to go to configure. This time, I'm going to load a network Modbus. So I'm going to go to configure new port here. I'm going to select Modbus client. I'm going to click OK. So the settings we're going to be working with are here. The Modbus client, it says port 24. It is a network port. So the first thing I'll go to explain, and you'll notice, you'll see this port screen, it does have its differences, but you'll see that once we get into devices, the settings on these two sides are pretty much the same. But I'll start with the port screen, and I'll make a point to point out the differences between the two. So here now in Modbus client on the network side, and again, this is what we're going to be configuring. I'm going to say Modbus client, and I'll just say it's a network connection. Typically in port name, the rule is, and you'll see this in all of our protocols, you want to give it a name that is relevant to you, that you'll be able to see this description and you'll know exactly what you're looking at. The reason being is the web UI, when you go on there and you go to look up information on this port, it's going to refer to it by this name. So make this something relevant, make this something you will recognize. Next here, you have the modes, and you have a choice of Modbus RTU or Modbus ASCII. And it's a fairly common question we get from people who ask, what is the difference between the two? So to help me in explaining that, I'm going to refer back to the presentation. I do have a slide that helps a little bit, gives us a little bit of an aid. Let me bring that up again. So Modbus RTU, we'll consider that in the present day to be much more common, and so much as to say it's pretty much exclusive that you'll find Modbus RTU on modern devices as opposed to ASCII. And the Modbus RTU will send data just as it's straight binary characters. It doesn't do any sort of manipulation of those. It doesn't change the way it's presented. By contrast, the Modbus ASCII, which again is, we'd say it's less common, and it's also less efficient with data, and I'll explain why here in just a second. So it takes those, say, binary characters, it kind of takes the hexadecimal groupings of those characters, converts them to ASCII. And what that results in is it effectively doubles the size of its messages, because it's doing the ASCII presentation of each of the characters in the binary, in the hexadecimal rather, which means it's going to be producing over and over again the ASCII characters representing the digits 0 through 9 and A through F. So that makes the message size of these ASCII Modbus, it makes these messages significantly larger, which is why I say it's less efficient. In general, I will say that the Modbus RTU and Modbus ASCII, as the messages appear differently, as the data kind of looks differently, these are incompatible with each other. If one device is RTU and if the other device is Modbus ASCII, and if you try to have those communicate with each other, you'll see with my example on the screen, at the top half of the screen, when the client and server are in agreement, you'll see here that we're polling certain points, and it's sending the information. I did not include the response because in this case it was a very long response. It was about 5 or 6 lines of just hexadecimal characters, but suffice it to say that we did get a response back. There were no issues whatsoever with it, again because they were in agreement. But take the example on the bottom half, and you'll see I configured the client as ASCII and the server I know to be RTU. You'll see it sent out the kind of similar request. You'll see that it puts some extra characters or some extra data on the end of that transmission. Along with there, you see that kind of CR and LF. That's just some additional things that it tacks at the end of an ASCII message. But the problem with this is that with these two, ASCII and RTU being incompatible, the client doesn't even recognize the message coming from the server, and vice versa. So what you end up getting back, and these are messages from the client side, you'll end up getting an error that it can't read the message. In this case, it's that length error that it refers to. It doesn't recognize it's longer than it's expecting, and it's not able for that reason to interpret the message that's being sent. So a message you'll get like this will be typical. And if you have multiple messages where it's polling, it's requesting data, that error will appear with every message that Modbus sends out. So if you're troubleshooting an issue and you look at the communication stream, there will be no question that just every time it tries to send a message, it's getting an error back. So for that reason, it's very important that the two match. And again, as I said, and really our recommendation would be always default to Modbus RTU and only use Modbus ASCII in the case that you are communicating with a device, and typically be an older device that does not support Modbus RTU. Now, in the case of the Orion, under the, if you set up the Modbus server, it will let you choose, well, might be speaking out of turn here. Let me go back to here. And just so you see, we have two Modbus clients. For the sake of comparison here again, let's go ahead and set up under network. Let's set up a Modbus server just so we know what it looks like here. And right here under Modbus server, you'll see we can choose which of these modes it uses. And again, we say use Modbus RTU unless it's just not an option. And in the case of the Orion, Modbus RTU is an option. I'm just going to keep this down here and we'll go back to what we were doing here. So as is typical with network protocols, you'll have this information here you'll need to populate. The port 502 is default. The host IP address we will need to populate based on that end server device. So I know this device to have the following IP address right there, 192.168.2.171, and that's just the IP address that happens to be on my device. On the other side here with the serial connection, you'll see these data bits, stop bits, you'll see these configuration options that are typical of any serial connection that you've ever dealt with, should have these options here. So you just configure them in a way that the client matches the way the server's configured. Back over here on the network side, you'll see this checkbox for Modbus over TCP. To explain why that is necessary in certain cases. So typically, serial Modbus includes what's called a checksum. If you're not familiar with that term, it's basically a kind of an error check. And it includes that checksum within that Modbus message. Modbus TCP, which is what we have, just the network connection is Modbus TCP. There is already a checksum that is included within that TCP protocol itself. And for that reason, we don't include in the Modbus TCP, we don't put a checksum in the message itself. Now, when can that become problematic? That could become problematic in the case, let's say you have an application where you're doing a Modbus communication, but you're going through a conversion, maybe like a serial to a network or TCP conversion. As you can imagine, that serial message is sent with a checksum within that message. When it gets over to the other side, it's in the TCP format. Now, that TCP is not expecting to see a checksum, so it doesn't check the checksum. And when the client sends a message back to the server, it doesn't put a checksum within the Modbus message. Again, because the TCP protocol itself includes a checksum. As a result, the serial side doesn't see that. So really, you have kind of two-way failure of the checksum. In that sort of special case, that issue is resolved by checking the Modbus over TCP. That tells the client device to look for a checksum in the Modbus message. And on the serial side, it makes sure that the client includes checksums in the Modbus messages that go to the server device. So in the special case like that, you'll want to check this, and that could fix any issues, again, involving a switch or a conversion from serial to TCP. Let's see, up next here, we have the reconnect delays, and these are in the case where you lose your connection. You kind of lose your link, your communication with the server device, where the first time it tries to reconnect, it will wait 1,000 milliseconds or 1 second. If that's unsuccessful, and this is to prevent maybe bogging down the server with these reconnect attempts, it will increase that delay duration every time it does it until it reaches the maximum value. And then from here, by default, every 30 seconds at the max, it will attempt to reconnect. That's what those are for. The option disconnect on timeout is kind of a special case. Typically, you would use this, and I won't go into detail for that reason, but if you're using a device, maybe like a network to serial bridge is the only time you'd really consider using that checkbox. If you have a case where you might need it, if you'd like to talk to us in detail, certainly please reach out. Enable response timeout, the option here, you'll notice it's checked by default. If it is checked, and let me click accept up here just to accept the changes I made. So this enable response timeout really does nothing more but enables this field here, response timeout, where you can specify how long a response is not received from the server device before the device times out. Now, it's worth saying, of course, there has to be a timeout. Here's where you can specify it yourself, and you'll want to check that box in conjunction with that. If you uncheck the checkbox, and of course, as I said, there must be a timeout at some point, that timeout defaults to 10 seconds. So if you have this box unchecked across the board, any device you have configured here will time out after 10 seconds. And then you have this here, a pull delay. If for some reason you need to put a delay on the pulls that go out. And typically I wouldn't touch this in case you're encountering an issue that might justify it. But it is here if you need to. And back on the serial side, you'll see we have these parameters that, again, you'll see on other serial connections. You kind of tweak these as you get into situations that, that require maybe some additional time. Okay, with that said, and apologies if I've confused you by having this open, I'm going to go ahead and minimize that, and we will focus on just the Modbus client on the network, the one we're going to be loading to our Orion. So now you click add new device, just like any other screen. This will add a new device, and we'll give it, again, a description that's relevant, and I'm going to call it M660 Modbus. It makes sense. So device address, this is just the Modbus address for the device, and you'll see here we have it set to 1. Now we're going to take our queue by what is configured on the Bytronics end. If I go to settings and I go to protocol, and this is not a Bytronics webinar, but you'll see slave address here is configured as 1, and we'll want to make sure, the important thing is that what the server device is set as and what this field is set as absolutely must match. If they don't match, then the messages aren't going to get to where they're going, plain and simple. So here's that response timeout field that I kind of explained a little bit ago. Accompanying that, it does have a number of retries you can set also. So up here, I'm going to touch on this area, with the pre-configured point lists. I'm going to touch on that when we get to the inputs and outputs. So bear with me on that. Modbus routing. Modbus routing is an option that you can use it to forward messages from a server device, kind of a pass-through sort of thing. And you would use it in conjunction, if we go back to the server port. I'm not going to jump back there, but there is a corresponding option on that server screen called message delivery only. So by checking the checkboxes on each side, in the Modbus client, it'll take the points that it gets across from its devices, and by having that box checked and the message delivery only box checked on the server Modbus, it will pass those points from those devices through to, I guess, what in a typical scenario would be passing those points direct to a SCADA master. So that's the purpose of Modbus routing. You'll see that it is unchecked by default because that's not a very common scenario. Smart reading. Smart reading, you'll see here, is checked by default. Smart reading, it actually allows the Orion to pull just a range of registers, even if those registers are not consecutive, if they're not consecutive numbers set up in Modbus and on the server device. So when you ask for the certain range of points, a typical device will respond with just all the points they have configured in that range. But as the caveat, some devices don't support smart reading. And if you send it a message asking for a range of points and it finds that certain points in that range are not configured on the server device, it will throw you an error in response. So in that case, there are certain devices that won't support this. And if you come across a device like that, if you're getting errors, the thing to do would be to uncheck that box. If you do that, then it will ask for the points individually. It'll ask if you have maybe consecutive number of points configured. It will ask for that range, but if you have a gap in that numbering, each gap then would constitute a new message. So that not doing smart reading, and if you have a lot of gaps in your point lists, could constitute a, I guess, unnecessary data being sent to request those points. It's just inefficient. And then the coil, read, and write, these apply to your 0x and 1x points. And it can read per message a maximum of 1,000 points by default. You can set these to whatever you need them to be. By the same token, the register read and register write, we'll actually get to see register read once we get further on in the demo. By default, that's set to, it will read a max of 125, a range of 125 registers, and it will write 100 by default also. Again, something we'll show the register read later, just so you can see in the communications how that gets reflected. This force 4x multi-write, this is another case where, as Jeremy had said, function code 6 is writing, and it's writing to a single register. There's also a function code 16, which we refer to as multi-write, which allows you to write to multiple registers in one command. A lot of devices will have both of those enabled. You will have some devices, for example, that will disable 6, or maybe they will not allow 6, with the intention that you would just do your single register writes using that function code 16. So that would be a multi-write to just one register. If you find you have a device that doesn't support function code 6 and only supports 16, the resolution for that is you come in here, you check this box. Hopefully that makes sense. The next option is D-word order, or I would say this is double word order. And I've got a pretty robust explanation for this one because, again, this may be the most common question we get on Modbus. You'll see we have choices of Intel, Modicon, and Motorola. Without the context, you'll look at these and you'll have no idea. But I have an explanation for you. And to provide that explanation, I will go back to the presentation. So about double word order or D-word order. This, one thing worth noting is it really only applies to when you're sending multi-register or multi-word points across. So 16-bit values, single register, they are always transmitted the most significant bit first. Another way of saying that is it sends the big end first, or that's what we refer to as big endian. When you're sending those larger values, those multi-register values, the order of transmitting that data can vary, again, depending on device. So if we take, for example, a 32-bit, and if you use the sequence, so if each byte, of course, a byte being 8 bits, it constitutes the sequence of data. Will refer to each byte as a letter, and it will be A, B, C, D. So if that data gets sent as A, B, C, D, the big endian way to present it would be not changed. It would be A, B, C, D. Now, as Intel started to grow, Intel being used in devices got big. Intel tended to use little endian, and you can kind of see it uses the least significant bit first, and it went in kind of reverse order. So then your order, as far as the bytes go, would be D, C, B, A. Certainly, if you get the big endian and little endian mixed up, your data will go through, your data will not make sense. And then least common of the three, in the case of Modicon PLCs, they did that byte ordering even differently. They did C, D, A, B. And I add the note here that manufacturer documentation should indicate the endianness. And I hate to say that may be wishful thinking. I've actually struggled to find that information. in device in manufacturer documentation, they should be able to have that information for you, if not in the documentation. Hopefully their support staff may, but there are certainly ways to figure this out. With that said, Big Indian is Motorola, Little Indian is Intel. Modicon PLCs, probably a lot less common now than they used to be, would have its own arrangement that is really neither necessarily Big Indian or Little Indian, and technically in a way it's both. So so not to confuse people any more than you may already be confused for those who didn't get that. So let me jump back into NCD and move on. So that was the word order. You see your choices here. I'm just going to pick Motorola. It doesn't make a huge difference. Time zone here, with the timestamps, you have the choice if it's going to send local time or UTC. That's just use the time zone setting that's relevant to you. And this section down here, I would consider to be near obsolete, as these are typically used with PLCs. I think two of them, the SER and SOE, are specifically Modicon. But when you have an application like that, these different addresses are pretty much, you see kind of SER would be more, well, as opposed to trying to explain it, these are just different things. You can put code in here that would work in conjunction with Modicon PLCs. Again, if you have an application where you feel like you need these, say if you're working with older devices, older PLCs, and you feel like you need to put some information in these fields, get with us directly. We'll certainly help you through it. But I will say that most of you will never need these fields. Now that we're done with this screen, we will click accept. Now we're going to start putting the points in. So you'll see, at the start, we don't have anything here. And that's, of course, if we didn't set up one of the defaults. If you're building a list, of course, you can't, there'll be a plus sign here, but you can't add points from this all points tab. You'll need to go, if you're going to add discrete points, click the discrete tab, click, and then, I'm just going to type in any name. Honestly, I'm going to get rid of this, but you can set up a discrete point right here. And, you can add additional points too. As you need to right here, you can build a list manually if you need to. Let me get rid of these. Again, the exact same thing goes for analog. You can click plus, you can add points also to build a list. So, and I'll go through, we've covered this on other webinars, but a convenient thing is we have our default point lists here. If you do not find a point list that goes with your device, and let's say you have multiple devices of the same type that you need to configure, the great thing is we have a major time saver in that the first time you can put that list together manually. Once you have done that, you can go back to this screen. If you click the button that says config to default file, you can enter a company name, you can enter a model, a name for the device model. And when you click OK to save it, it creates a default file that becomes an item on this list. So you'll then have a default file here that you can select, and any of the same type of device you program in the future, you can use a default file for it. What I've done with this Bytronics meter, I will go to Bytronics. I've set up a point list just for this power hour. I will select that. I will click accept, and then yes. Let's try that again. Bytronics, power hour. Yes. Well, that's inconvenient. Where are my inputs? I'm just going to select another point here. I'm not sure why that's not working, but as people on the webinar forgive me, as you'll see under outputs, I just had the discrete points, or inputs, I had the discrete points selected. So we will work with it now. We'll select M660 power hour, accept, yes. And now there's our point list. So to cut to the chase here, since I pre-configured this, I will hold, just like in any Windows application, if I click an item on this list, I hold Control and select A. That chooses all the points. I will move them straight over. Okay. So to move on with this a little bit, let's just take this point here. I'm going to go through the different types and just show you how you select them for each point. You can select, so for all these points, you see we have them set as one register integer. So that's going to represent a 16-bit an analog, just kind of standard analog input point. If you need to, you can also, if you're setting up discrete points or binary points, you can do 1-bit discrete. That's going to be the most common. There are other choices here for different, longer integers, longer floats. If you want to use those are on the list also. But you'll see these are all integers. These numbers, I did just kind of want to confirm with you that they come from the Bytronics screen. If I can just click into here, you'll see here is the standard point list, and you can go through to check and just confirm that those match. In this case, I know that they do in fact match. If you need to, if you have to set different pull groups, you can do that under the pull group screen. And of course, you use the drop down to select which one. And of course, as usual with your analog points, you have your min-max values. Let's go take a look at outputs. You'll see we just have 4 to select here. I'm going to select those. I'm going to move them over. And again, with your output points, you can select 1-bit, just a discrete kind of binary output. You can actually make use of these trip close pair options too, and you'll see there are all sorts of options for that. The recommendation I'll give you is if you're trying to figure out which of these trip close points to use, I would refer you to the document for Modbus, the Modbus client document. It has a table where it will describe these trip close options. It'll actually have truth tables for these that will help you select, how to choose your points and which one to assign to which. So that's a very helpful resource. And again, we'll find that under the Modbus client documentation. That's under help documentation, where we have a nice kind of a treasure trove of documentation for all of our different protocols. So with that said, I will close out. You'll see we have other things. There's the 1 integer mask write. As Jeremy mentioned, the mask write represents function code 22. You may have a device, if you try to use that, you may have a device that doesn't have function code 22. That's something you'll want to be aware of. And you'll see, you'll have an error thrown when you try to use that function code in your communication log. So something to bear in mind. Other things, you have your multi-register stuff too. And that's going to do it for outputs. The pusher, if you have multiple devices set up, and if you have the pusher, you can select certain points from one of the devices. The pusher will allow you to share those points from one server device with another server device. So that is the purpose of having the pusher. With that said, I'm going to go File, Save, and I will call this Power Hour Modbus. I'll go ahead and save that to my main folder there. And now with that done, I will jump over to the Orion MX screen. Now remember, there are multiple ways to send these files. You can use the command window here in NCD to send the files. If you prefer doing it, it's certainly not wrong to do it that way. You can use this screen too. You can drag files and drop them right here, and then those files will populate on a list and you can click send. I'm going to click select files, and I'm going to go ahead and go to documents, NCD files, and I'm going to find where I put that file. Let's see, Power Hour Modbus, open, and I'm going to go ahead and send that over. So wait just a second, it's kind of loading on this page. And send. So now with the Orion MX, right, we go into a short power cycle. That's after I selected on the list Power Hour Modbus. Okay, so now our work in NCD is essentially finished, but I will take a look. I will show you what everything looks like on the Orion MX's web interface. First place I will take you is View Comms. You'll see I get an error here because we did just restart it. It's not all the way restarted yet, so I will do a refresh. As I see, it's taking a little longer than it typically does. That's fine. Let's refresh. I'm having a technical difficulty once again. I will try to select that file and resend it. My Orion MX seems to have a difficult time getting through its initial startup. So I will open and send. Yeah, this problem might linger. Hold on just a moment. Unable to communicate. Yeah, can't honestly say I know what's going on here. So let me jump back. I accepted that. Let's remove these ports. Sometimes it gives us an error if we set up a Modbus port and don't fully configure it. So let's just not leave anything to chance. Let's go ahead and remove these. Save. Okay, I'm going to try this one more time. Open. Okay. There we go. That was the issue, that I had to delete those Modbus ports. And this is actually something I had encountered recently in another case. Just for the sake of showing you, I will try to show you what that error said. Usually get, yeah, kind of like right here. You get errors here about your port that's configured. Because it sees a Modbus instance configured, but since it doesn't see points configured, you have an issue with Modbus, which then forces an error on the Orion. Now that is a troubleshooting tip, kind of an accidental one, but certainly that is something to look at. Make sure any Modbus protocol instance you configure, make sure you do have it fully configured with points and everything. So now you'll see the communication stream here is going through kind of as intended. Let me pause this. You'll see here what it's reading, and you'll note that all the points I configured are the 4x points. So you'll see that first it's reading 40001 to 40125. It's requesting 125 points. So again, that ties back to that screen in NCD where you were specifying the max number of write and read points. So it reads 125 points, and then it goes back and cleans up with the remaining 21 points. So there's communication. You'll see it's pretty straightforward the way that is. So let me also jump now to data values just to show you what the data looks like. We'll go to inputs. And you'll see we have some points here, system frequency. Now you'll see this comes in as 5998. Of course, this would need to be shifted, and we can do that certainly in NCD, shift it by 2 decimal places. The same actually goes for voltage also. You'll see here volts A. We have a pretty ideal 120.03, very close to that kind of standard 120 that we think of. Of course, we would need to shift that 2 decimal places over. But the data we need is all here, or at least all we have access to. Certainly this coming to my office, not on a live system. I have a voltage and I have a frequency, and then any points that derive from that. But you'll see all the data is here. As far as showing Modbus configured, that's just about all I need to show. And with that said, I will close out by saying, that was a very basic example of Modbus. If you're working on a Modbus application yourself and you need help with it, feel free to reach out to us. And here in a few minutes, I'll give you information on doing just that. But before I go into closing, Jeremy, is there anything I need to address based on the questions that came in?
No, I answered most of them, and we'll follow up on a couple others.
Okay, excellent. I appreciate that. Then with that said, I'll jump back in here to the presentation. And as we go into our closing, we'll conclude the way we always do with information about the resources on our website, NovaTechAutomation.com. This is the community, customer community. Again, it's NovaTechAutomation.com/community. You can also get to it from our main website on the resources tab at the top of the screen. You can access the community that way also. If you come on here, you will find, I would say most notably, an archive of past webinars, including this one. We will put it online and you'll be able to find it under training and webinars once we get it up there. But you also have a search bar. You can search for any Orion Biotronics related topic here, any documentation, any webinars, any resources that we have that pertain to your search query will pop up right on the screen. So you'll have quick access to whatever you need. And here also you'll see some immediate support options. First off, you can call our office directly during business hours. Phone number is right there. There are support email addresses, and then you will see the link right there that allows you to book a call with an application engineer, and that is someone on my team. Again, we are a sales engineer team. We kind of function also as application engineers. The customer support site is here. This is support.NovaTech Automation. You can go here to get NCD. You can come here to get firmware. You can come here to look up, just the stuff related to the Orions that you own. You can find here also. So this is the support site. And lastly, to just revisit that community screen, when you click that link that says book a call with the sales engineer, it will take you to this screen right here. Where essentially you can set a meeting yourself. You can set up a date and time that works for you, and you can select who you'd like to talk to. Now, just as standard, you could select anyone. If you don't care who you speak with, you send it to anyone. We will find the best person, really kind of the best person on the topic you'd like to speak to, also based on their availability. And that person will be on the call to help you, answer your questions, show you if there's something you need to see. Anything, any way we can help, you can set up a meeting right here. And you'll see our list of engineers you can select individually. You see there on the right side. So that's a look kind of at Modbus. I hope you guys enjoyed the webinar. If you have any questions, certainly we have some to address. We will send a follow-up email. Feel free to reach out to us directly as well. So again, thank you everyone for attending. Contact information is here for Jeremy Anderson and myself. It is just our first name and dot last name at NovaTech Automation. So with that said, guys, if you have any more questions about Modbus, look forward to hearing from you. But I hope you enjoyed the webinar, and everyone have a fantastic rest of your day. Thank you.